Hello everyone, this is Haven and Code and welcome to your Unity Audio Spectrum tutorial. In this tutorial we're going to make objects move to the sound. We're going to be measuring different parts of a sound and we're going to make these 4 sexy cubes move to the beat. Okay, it's gonna get ham up in here. Okay, so in this scene we have 4 different cubes: a plane, a camera, a point light, and a sound. This is what the sound sounds like. Yeah, it's kinda shitty, but it just plays 4 different notes. It plays 4 different octaves of C. Let's see what this sound looks like on an audio spectrum analyzer that's already been made. This is Ableton, and this is how I made the sound. I made it with operator, and it plays 4 different notes, different octaves of C. We play the first C note, which is C1, then we go up to C3, C4, and C5. And this is what it looks like on the analyzer. Okay, so when the first note played, it was playing around 64 Hertz. And then when the second note played, it was playing around 256 Hertz. And then 512, and then 1024. Notice how these C notes are all a power of 2. When you go up an octave, you just multiply that by 2, and it gives you the second octave, which is kind of weird. You wouldn't expect that. But yeah, so let's see how we can make these cubes move to that sound. We're going to have to utilize the frequency 64 Hertz and then 256 and so on. So we're going to be using the audio listener. So the camera is going to be listening to the audio, and then we're going to make these 4 cubes move to that sound that the camera is listening to. So we have to make a script. And what I did with these cubes, in order to reference these in a script, we have to give them a tag. So let's give it a tag. Let's just call it cubes. Okay. Yeah, let's do capital C cubes. And I'm going to add these tags to the cubes so I can reference them in my script. Alright, now let's add a script to the camera. Let's call it Spectrum Analyzer. It's just going to be a JavaScript. And in this script, we're going to be referencing what the camera is listening to. The specific method we're going to use to get the audio data is audiolistener.getSpectrumData. And that method takes 3 different parameters. It takes the number of samples, which channel that we're listening to, and the window algorithm that we're going to use to get the data. So we're going to say we need 1024 samples. It has to be a power of 2. We're going to do channel 0 for both channels, and we're going to use the FFT window hamming. Okay. And this will give us a float of different values. It'll give us an array of floats. Okay. So, before we talked about the different octaves of C and how the C1 is around 64 Hertz. C3 is 256 Hertz. C4 is 512. and C5 is 1024. Okay, and this spectrum array holds an array of 1024 values, and those values contain the volume of certain frequencies in sound. Okay, so the first element in the array, spectrum 0, is going to contain the volume of 0 to around 21 hertz. Okay, this whole array represents from 0 to 22,050 hertz. That's half of 44,100 hertz. Okay, so if we're dividing all those different frequencies into 1024 parts, we're going to get around 21. So 22,050 over 1024. That will give us 21.533203125. Okay. So when the low note plays, it's going to play around 64 hertz. So we want to measure the volume of that. So let's see what that's going to be, what element in the array that's going to be around. So we just do 64 over 21, and that'll give us around 3. Okay, so I'm just going to get a variable to get how loud the lower note is at the time of listening on this frame, and I'm just going to add a couple values in that array. Okay, and I'm going to do the same for these other 3 notes. So now that we have that, let's just log that. And we're going to call it low. Okay. Alright, let's see if we have any errors. We definitely have an error right here. So I'm just going to delete this. Okay. Let's go to Unity and just play it. Alright, so let's look at what the console gave us. Console gave us, when the sound first played, the value was 1. Okay, and then when the second note played, the value was 0. So that's working. Let's do the other ones. And I'm just doing this from memory. I know that these values in the array contain those specific notes. Okay, notice how on C5 I added more different elements in the array. The reason for that is because when we use a windowing function, it's just going to give us like an array of elements where it thinks the sound is. It's not going to be exact every time because it is a lot of data that it's dealing with, and it's supposed to be really fast. That's why they call this a fast Fourier transform algorithm. They're just taking audio data and they're giving it to us in the best way possible, like as it can measure. And the reason why I had to add 6 of these instead of just 3 is because it just wasn't doing a good job, that windowing function. Okay, so now we need to get all the cubes in the scene that we want to move, and then we want to move them somehow. So I'm just going to get all the cubes by using a method called find game objects with tag. Okay. And the tag that we used was cubes. And I'm just going to do a for loop to loop through those different cubes and find each one by name, and then we're going to alter the size of it. So for var I equals 0, I is lesser than cubes dot length I plus plus. We're going to do a switch statement, and we're going to say, alright, if this is the cube C1, we're going to say cubes I dot transform dot local scale dot y equals C1 break. And we're going to do that for the rest of the ones, for the rest of the cubes. The transform, I'm pretty sure this is the model matrix for each cube, and we can say, alright, I just want to edit the y scale and say you should scale it to C1 units, whatever value is in C1 at the time of this frame. Okay, so we can take the debug out, and this should make our cubes dance to the beat, man. It's gonna be ham. Let's see if I have an error. I probably do. Nope. Alright guys, there you have it. You know how to measure the different frequencies in sound, and you can make a spectrum analyzer. It's pretty fucking badass. Okay, so if you want to make a full spectrum analyzer, you're kind of hindered by JavaScript right now. Obviously you can't do a for loop through 1024 elements in an array, because that will just make your program crash. But you may be able to use some different language, possibly, if they give this API to you in C# or maybe some other .NET language. It'll be sweet. So if you want to make a full spectrum analyzer of just like 5 cubes that represents the whole low, mid, high, and higher, then you want to add more than just this amount. Okay, and I recommend like looking at a different spectrum analyzer just to play with the values, because really you're not really doing a whole bunch of math, you're just dealing with the artistic part of it, and that was the point of this tutorial. Anyway, have a good one.